Alright, let's talk about planes. Planes. You might remember at the very beginning of the year, I discussed that planes are flat surfaces that extend forever in every direction. And throughout this year, we've only been dealing with geometry on planes, on a single plane, which is a sheet of paper, a flat surface. And so all of the rules of geometry that you've learned thus far are applicable to planes. However, as you might know, most of us are not two-dimensional. Most of us in this room or on this internet exist in 3 dimensions. And because of that, we want to learn more about the 3-dimensional world, hence 3-dimensional geometry. And so we will begin today by just discussing planes and considering how planes interact with each other. Today's painting is along the river Qingming during a festival. This painting is 10 inches tall and 18 feet wide, and what we see here is just one scene from this immense painting of a group of sailors or merchants trying to bring their mast down on their boat before they go under the bridge. Here you can see them scrambling on the stern of the boat, arms outstretched and worried. You see a few people throwing ropes, others trying to bring the mast down. You have young men on the bridge getting ready to push the boat in the other direction, or maybe one of them wants to jump onto the boat. And it's a very delightful, lively scene, quite humorous. It's from the year, or around the year 1100. In Chinese, the painting is called Qingming Shanhe Tu, which means the Qingming River painting. So open your books to page 357, and we will discuss our core concepts of planes. We've already learned, of course, that if you have 2 points, you can use them to make what? Any 2 points can be connected to form a line. We also have discussed that a line is made up of a certain number of points. How many points are on a line? Trick question. A line can have an infinite number of points. Points don't take up space. We draw them as taking up space because it's a conceptual tool. It helps us see and do geometry to have these diagrams. But it's important to remember that when you draw the circumference of a circle, in theory there's no thickness to the circumference. There's no point in the middle with a thickness at all. It's a 0-dimensional thing. That's what a point does not take up any space. And so it's a logical idea that we represent with a very small image. So on a line, there's an infinite number of points. Our next question, though, is if you're looking at this image, you see it's on a big black plane. But if I have a line, how many planes can I put on that line? And remember, lines extend in either direction infinitely as well. So here's my plane and here's a line. Now remember that my plane theoretically extends infinitely in each direction, but I'm not going to draw that. I don't have a big enough monitor to draw an infinitely sized plane or an infinitely sized line. So I will settle with this abstract version of a plane and a line. So I have my infinite line and my infinite plane. How many other planes can I put on this line? So while this plane encapsulates this entire line, I can also draw another plane that passes through the line, but at an angle. And I can draw a second plane, or third plane, and a fourth plane. And so you see I could keep drawing planes, and planes and planes and planes. I could draw an infinite number of planes on this line, and they would all meet on that one line. They would all extend forever in each direction. On any line, there's an infinite number of possible planes. But what if I don't want an infinite number of planes? I only want one plane. How many points define a plane? How many points define a plane? 2 points define a line, and 3 points define a plane. If you have 3 points, it doesn't matter how they're oriented, you can use them to make a plane. It's hard to represent here on this two-dimensional screen, but let me give it a shot. Imagine a cube. We've all drawn the cube before. And in my wireframe cube, there's a dot here, a dot here. If I get in the right viewing position, all 3 dots will appear as a straight line. And on that straight line would exist my plane. And this infinite green line is the side view, quote unquote, of my plane, which extends forever towards me and away from me. And on it are those 3 dots that were suspended inside of my box. Given any 4 points, is it always possible to find a plane that passes through all 4 points? No. If I have 4 points, you cannot necessarily line them all up from any viewing angle in a straight line and make a plane pass through that dimension. Here's an example. Let me draw some rocky ground. And on this rocky ground, we need to place our telescope. So when I try to put this telescope on my rocky ground, I have to bend its legs or extend its legs in different ways. So this leg needs to go there, and this leg needs to come here. These 3 points make a plane. There's an invisible plane extending across all 3 of these points, allowing my telescope to be level. So the principle we need to understand here is that planes are going to have their own properties. Any 3 points can make a plane, and any line can have an infinite number of planes on it. Lines intersect, and when they intersect, we call that spot a point, of course. But when planes intersect, what does that location look like? If we go back up to our above example, intersecting planes form lines.